Hey everyone, Anshul this side. I'm an Android developer at Juno. Juno is a fintech startup offering crypto checking services in the US. Juno being a neobank, there are a lot of third-party SDKs that we integrated in order to allow users to verify their identities, adding bank account, and much more. Integrating these SDKs into our application made me realize the need for having a centralized manager handling all the end-to-end utilization of these SDKs. So that's what we are going to talk about today. That's why my topic says building manager over third-party SDKs for easier access. Let's deep dive into it. We'll talk about what happens if you are using SDK managers and what happens if you are not. Then we'll discuss what third-party SDKs are, their use cases, their basic utilization. Finally, we'll discuss about how can you build your own SDK managers and the principles to follow while writing your managers. Talking about with and without of a HDK manager. So suppose you have a HDK that you are integrating and your logic for including the initialization as well as whatever you can say your custom logics take up to 200 lines of code. Assuming that you want to integrate it at multiple places, suppose three places. Now what you will do is you'll be copy pasting a lot of code, adding a redundant boilerplate code to your file, to your three files, which increases the boilerplate code and thus leads to more error prone code. Because when making any changes, you might forget to upgrade one file and you might basically update the other one, and further it makes it difficult to migrate to a newer version of the HDK. So suppose you are using any HDK and a newer version is available and you want to migrate for enhanced functionalities, so you might forget to upgrade it at one place and you might do it at other place. So that's one of the issue that we can face without HDK managers. Now talking about with HDK managers, as we discussed, HDK manager would be a centralized file holding all the logic. So instead of copy pasting whole 200 lines of code, there would be some methods that you'll be using. Some methods, as in basically some methods exposed for the consumption of those boilerplate code. So earlier there were supposed 200 lines of code. Now there will be only a certain methods, say 6 lines of code that you will be consuming across the three files. So definitely HDK manager leads to reduced time of code. It further promotes easier migrations, as in as we discussed that it might there might be a newer version of the HDK available, or there might even be a new HDK for the same purpose that you want to migrate to. So in that case, you only need to upgrade your centralized file called the HDK manager, denoted to a particular HDK, and you don't have to make any changes to your certain fragments or activities wherever you are consuming it. Thus, since you will have a centralized manager, you don't need to. You will be basically handling all the error cases and exceptions and everything in a centralized file, making your code less error prone. This was all about what happens if you are using HDK managers and what happens if you are not. Yeah. So let's discuss some common examples of the HDKs that are commonly used across the projects. First is Google Sign-In. Google Sign-In is the most widely used for authentication purpose. So there's a common use case where you forget to log out of Google Sign-In properly, and that leads to improper sessions. But suppose you had a HDK manager built over Google Sign-In properly with methods properly exposed like login and logout. What you will do is wherever you need to log out from the application, you'll call the logout method provided by the HDK manager itself, and you don't need to worry about the internal functionality. You just have to define the logic once, and you can properly manage your sessions and everything. Other common examples are Stripe as a payment gateway. Then we have Firebase APIs for authentication, real-time DB, and many more. Mapbox HDK can be used for integrating map-related services, and Twilio as a messaging service. Moving on to what third-party HDKs actually are. As the slide says, pre-packaged libraries or tools created by external developers or companies to provide additional functionality or features to a software application. Basically, anything that you are not building yourself, but are consuming something built by an external developer or company to provide enhanced functionality in your own application. So, what are the advantages of using a third-party HDK? Simplify development. Since you are using a service that has already been in the market for some time, that simplifies your development. There are certain methods that the HDK is exposing. You just need to communicate with that and don't worry about the internal logic. Enhanced functionality. Basically, you are using the third-party HDK to provide some enhanced functionality apart from what you have built. Suppose we are taking the example of Google Sign-In itself. We are providing another functionality of Google Sign-In over and above the login using email and password method functionality that we might have. Accelerate time to the market. Since you are not building a solution from scratch, you are already using a battle tested solution that's have been in the market for some time. You can easily integrate it without worrying about the nitty-gritties of that, and thus leading to acceleration to your time to market. Again, some common examples would be payment gateways like Stripe. If you are integrating some payment gateway in your app, you don't want to build it from scratch, Stripe offers certain you can say the SDK for handling all the payment gateway scenarios, and thus and serve various use cases that the user might have. Apart from that, there are Mapbox. You won't be interested in building your own map service, so you can use Mapbox or Google Maps. Then Twilio for messaging services. Yeah. Coming to utilization of third-party SDKs. So utilization of third-party SDKs can be broken down into four major parts. First is initialization. Initialization is basically where you are initializing the object that provides you that lets you access the internal functionality of the third-party application. This takes your you can say SDK token that is provided via the SDK that is stored in your that is provided by your backend or is stored in your application itself. For example, Google APIs, you can get the token from Google Console. Then customization, since third-party SDKs are basically to solve your purposes instead of making the user feel like they are migrating to a third-party service then coming back to your app. So most of the third-party SDKs allow you customization itself, and you can customize the view, you can customize the logics as per your use cases. Then we have event listener. Event listeners are basically analytics. Event listeners for used for analytics and user journey tracking. Most of the third-party SDKs expose methods where you can track where the user is acting right now, where the user is moving. You can track user actions, and based on those actions, you can have your analytics classes pass it to your backend or pass it to your the storage wherever you are storing the user journey, and make certain actions in the background based on the actions of the user. Then the final and the most important part is result handlers. Result handlers are basically when you are using a third-party SDK, you are moving the you can say your user from your application to a third-party application, and so definitely you want to bring back the user to your own application. So that's why we have result handlers, mostly on activity result. You declare the on activity result in your fragment or the activity wherever you are starting, you are opening the SDK. So result handlers are basically for handling those results. Any event, the action user has completed the journey within the third-party SDK. Now they want to come back to the application. So in that case, you will have result handlers, and you can perform certain actions and move the user to correct flows based on that. Again, let's discuss why SDK managers. As we discussed earlier, instead of writing 200 lines of code in each and every file, it would be beneficial if we had a centralized manager instead of basically writing repetitive code, boilerplate code, adding the boilerplate code and making it more error prone. We'll have a centralized manager which will be used to access the whole code, the whole SDK related code. It will expose some methods and we'll be able to access it easily across files. So which makes our code very less error prone, because we'll be handling all the error cases, all the edge cases, all the custom logics, and everything could be defined at a single place. So which makes your communication with the you can say the SDK much reliable and efficient. Apart from that, it supports easiest migration, as in suppose you are migrating to a newer version of the SDK and some of the methods have been changed. So you just need to upgrade one file and you don't have to interfere with the consumption of the file, and the same methods would be work as they were working earlier. And it even supports, suppose you are migrating from one sort of SDK to a different sort of SDK. So that's also one of the use cases that SDK managers solve. So you can just change the core logic of the SDK. Basically, you can change the SDK to the new one, and you don't have to worry about its consumption, and as long as the return type and everything remains the same. Here I've built a template for SDK manager. This can be extended to, you can say, your APIs, as we were discussing earlier about Google sign-in. So yeah, let's see what I've declared a class over here called SDK manager that takes in resources, shared preferences, JSON, and some other, you can pass on other classes. And this I've done via dependency injection. You can, if you are not using dependency injection at this point in your project, you can basically pass them as a constructor. You can have the manual dependency as well. Apart from that, you can add your custom classes. If you have some custom classes used across the project, you can just add them over here. Then you can access them across the SDK manager. I've declared some variables called variable 1, variable 2. These I have kept private because I don't want them to be accessed outside the file. These are some local variables associated with my custom logics. Then we can have some getters and setters for these sort of variables so that we can access them outside the class via we can set them via from outside the class. If we have some custom dependency on our backend or some other file, suppose we are initializing the variable 1 based on some output resulted from a different job. Another thing that I've declared over here is a HDK object. HDK object is nothing but the main object that you will be that it will be used to call the methods of the, you can say, SDK. So suppose we are working with Google sign-in, so this SDK object will be Google API clients. This object will take care of all the initialization logic, all the customization logic, result handlers, and everything. So basically, this is just a basic template. You can add you can add several design patterns to it, and yeah, majorly all the classes and everything should be populated on the top itself. Basically, all the via constructor dependency or anything, so that you can easily access them. Moving on to some basic methods that I've defined, the major methods I've defined actually. We were talking about we were talking about the utilization of SDKs. So the first important method is initialize SDK. What we do over here is we pass a SDK token, passing SDK token and some additional parameters that we want. So we'll be making use of our, you can say, this SDK object over here, and SDK object would be used to add on, you can say, initialize the, for example, we are using Google API client, so Google API clients plus its methods, whatever customization and whatever, you can say, initialization code we have, we put over here. I've kept this function public because I'm assuming that we get some key from some external dependency. So I want to call this function via the SDK manager's instance from outside this class. So that's why I've kept it public. You can keep it private as well based on the SDK that you are consuming and based on the data that is dependent on. Next, we have is a set event listener. So event listeners are basically, as we discussed earlier, most of the third-party SDKs, you can say, give you event listeners. Event listeners are used for tracking user journey and the actions that they're performing within the SDK, because you want to perform some custom logics based on the SDK, based on the user actions over there. So I've kept it private because I have a suppose analytics class that I'm passing through dependency over here in the constructor itself. So I can make use of that analytics class and pass the events returned by the SDK to my own custom event trackers, or you can say some analytics platforms that we use in your project. Apart from that, there can be some custom logics that some custom functions that you want to execute based on certain events, so you can handle over here. Final method is handle result method. As we discussed earlier, there's, you can say, on activity result. So wherever your fragment or activity is listening to on activity result, you can just pass on the result that is received from the SDK and pass it on over here. I kept it again a public function because on activity result would be there in activity or fragment itself. So I'll just pass the data returned by the SDK to the SDK manager, and it will be handled around, you can say, using some local variables that are declared or some additional parameters that we are passing from outside. This is the basic template that can be used for, you can say, building your own SDK managers. Apart from this, the SDK manager contain your custom logics around caching and everything based on the use cases and based on the type of SDK you are integrating. Main thing to consider while writing the SDK manager is basically you want to follow your proper design pattern. Suppose we can make this SDK manager a singleton class if that works for us, if that pattern works for us. Apart from that, we need to make sure that we are following solid principles as well as other, you can say, uh, design patterns. Yeah, so that's what all from my end. I'm open to any questions. Over to you, Madonna.
Wow, amazing. I felt like it was a pretty lightning talk. And I love the fact that you were talking about SDKs because this is something that I've worked on and it really resonated a lot. But I had a question for you, which I might be, because I want to understand. So, what is this is for you. Can you hear me?
Yeah, I can. Yeah, go ahead.
Okay. I saw my screen move like this. I was like, what's happening? So my
Yeah.
question for you was, I know this might sound very funny, but we have libraries, right? And
Yeah.
we have SDKs. Are they the same thing for people that don't know?
Not the same things. Basically, it depends on the, as I was talking about Google sign-in. So that's actually a library, you can say,
Uh-huh.
provided by Google, and SDK is a different thing, you can say, provided by, you can say, some custom operations happening in the backend, basically some functionality that we are accessing. So that's a SDK and libraries. Yeah, it's a interchangeable thing, but yeah, with a slight different, you can say. Then we have APIs as well. So we use these terms interchangeably: APIs, libraries, SDKs. Yeah.
Okay, cool to know. Now, if you have any question, please drop it down. But I'm just gonna show you the reaction if you didn't get to see them. So it's pretty cool. People clapping. Great, bro. I like that. I love that you got this because it also inspires me as a speaker. And then I love you got this too. And I like this one too. Good vibes. Yeah, so I think the other question I would, I think we still have some time. We just want to see if anybody has any question. Please, if you have any question, just drop them there. I think as somebody sent another reaction, I just want to show it to you. Feel motivated.
Yeah.
And then amazing perspective. I love that because it just shows that people are engaged and they love the talk. So the other question that I might have for you is that, do you think, so what kind of software should be made as an SDK, or what should be an SDK and what shouldn't be? And I'm asking in terms of, let's say I'm building something that's going to be reusable at my company, and I'm wondering, like, should I make this a library or an SDK, or what should I do? Or should I just build in its component that I can use?
Yeah, it depends on the, basically, as you said, depend on the code that you're working on. So if it's a service that other people might benefit from, so as we discussed, there was Stripe. So we don't want to build my own, you can say, whole payment gateway, the whole nitty-gritties I need to handle myself. So in those cases, I would
Yeah,
prefer that we build a HDK out of it so that we can sell it as a separate product itself.
amazing. And that makes sense because the SDK I used to work on too was more of like an AR, AR code, like augmented reality. So
Yeah.
people would implement that SDK on their application, and that totally makes sense because sometimes you don't have to keep reinventing the wheel. And if somebody is already doing it a good job, and you can pull the SDK also. And also,
Yeah.
another way you can actually, this is actually a good point where even developers can start generating income from some SDKs if they want to. Yeah,
You can sell it as a separate product. So yeah, that's why. Yeah.
exactly. Yeah. I also want to share this particular clap from Mohsin, from all the way from Berlin. I've met him in person, pretty great person.
Yeah.
Cool. I think if we don't have more questions, do you have any parting words? If we don't have any questions, we might end early. Just
Yeah.
trying to check my calendar. Yeah, because I think we're early on time. So yeah, if we don't have any more questions, we might have to end it early. And I'll see you all next time. I think we'll stick around. We'll still have more amazing topics. So let me run through just the topics that are coming up for our guests. So we have Battle of the Titans, RX Java versus Kotlin coroutines. That's an amazing one. We need to stick around for that. We have Impact of Framework Choice on Your Application by Ruben Peters. And then we have Building Accessible Apps with Jetpack Compose, which is amazing, by by Carol. And then we have Six Things View Binding Teaches Us. Wow. These are all great talks.
Yeah.
Okay. Then we have Japa Compose Performance Tips and Tricks. Amazing. And then we have Unveiling the Unseen Threat, Demystifying Memory Leaks in Android by Yves. And then we have Blast Off. Wow, this is amazing. Blast Off, Managing Hundreds of UI Update for Emoji Cannons by Priyata Pruz, which is amazing. That's interesting. Emojis. Have you worked with emojis? I've not.
No, I haven't. Yeah. That we will learn full. Yeah. Great.
Yeah, definitely a talk to stick by for and watch. And then finally, we have Designing Jetpack Compose Architecture for Gradual Migration from Fragments at Turo by Pavel. And that's it. Those are all amazing talks. Please stick around, or tell a friend to tell a friend to come listen to the talks. So bye.
Okay. Thank you for having me. Yeah.